This is the 7th video in a series of screencasts which shows how to recreate projectile motion. In this one I'll show you how to insert an image, attach it to point P and make it roll with the angle of inclination of the velocity vector. Alright, so here's the insert image button. So I'll just click here, try it again. Okay, so there's my image which I'm going to attach to the point P. Alright, I need some control points, so I'll type corner and I'll use the automatic entry, and this one I need to know its name. It's called pick 1, so I'll just go pick 1, comma, corner number 2 I want, enter that one, press the up arrow, and here's one that I typed earlier, pick 1, comma 4. Okay, I want my control point for this one to be located at the midpoint of those two, so it's close to the center of the diagram. I chose this position because I wanted it to simulate. I can't get that point, that label back down there, sorry. And there it goes. Okay, so I wanted this point to simulate the center of gravity of the rocket. Alright, now I don't need that anymore, and I don't need G anymore either, so hide both of those. Right, first thing I'm going to do is rotate the image around the center. So I'll choose that tool there, select the object, the center, and the angle needs to be arctan of V underscore Y over V underscore X. Press OK. Alright, now hide the background image. Now I want to dilate this one by the factor K. This is just a slider that I made, and it goes from 0 to 2. Alright, so I'll go in here and choose enlarge. Enlarge is the Australian version of Geogebra, is equivalent to dilating. So click on the object, click on the point and the number K, press OK, hide the background image, and now I need to create a vector in preparation to translate the picture to this point here. So then I come in here and change this to translate object by vector. Choose the object you wish to translate, choose the vector, and there you go. Alright, so now if I just select that and turn that off, and also turn this off. Alright, so there's your image inserted, moving with or rotating with the angle of inclination of the velocity vector. So don't forget, you can dilate with this one, twice the size, about normal size there, and back to whatever size you want. And there's the velocity vector components, and don't forget you can dilate those if you need to with that there. Alright, now a couple of problems occur. What I'm about to show you won't affect many people. It depends if you want to have angles bigger than 90 degrees. This problem will affect you. So if I make this, say, I don't know, 120, press enter, you can see the rocket is now facing backwards. So in the next video, that's one problem I'll show you how to get around. I'll put this back to an acute angle. And another issue, which will again not affect many of you, if you want to muck around with negative values of the horizontal component of acceleration, you start getting weird things like this happening. Okay, so I'll also show you how to get around things like that in the next video. Anyway, I hope this has been helpful. For the majority of users, you won't need to see the next one because you'll have that set at an angle between 0 and 90, and this one you'll probably always leave fixed at 0. So no need to watch the next video if you don't want. Thanks very much for watching. Hope this helps you and your students in the study of projectile motion.